Hello everyone, and welcome to the part 1 of the two-part series on understanding AWS IoT using or with Node-RED. Alright, now as with many of our videos, let's go through a small presentation and we will then jump into the demo. Alright, now first things first, let's understand what IoT is, or Internet of Things is. So basically, Internet of Things is when you have a lot of devices connected to the internet which can be remotely controlled to get the job done. Now, in front of your screen, you have a house which has an IoT bulb, right, as well as a fridge, as well as a generic IoT device. So, what can happen, or generally how IoT is utilized, is you'll have a phone or some kind of a controller, maybe a web application, from where you're gonna hit a command and let's say turn on the bulb, right? Or you can reduce the temperature of your freezer or fridge, right? So that is something you could do with this Internet of Things. Basically, these are things that are connected to the internet, and they can be remotely controlled. Now, in addition to that, what you could do is also have these things send information to, let's say, a backend server or a database, from where then you can draw conclusions as well as have dashboards and watch the status of your devices. Now, these devices are not only available in the house, but industrial IoT is a big thing as well. So here you can see that similar or in an industry or on a workshop floor, a lot of devices that are connected over internet, and they can be controlled from outside. Generally, with industrial IoT, you don't really control devices via phone, but concept kind of remains the same. You can also connect IoT devices which are on top of, let's say, moving vehicles like the one that you see on your screen right now, and try to get the information about them, like for example the fuel level or what kind of mode that they are running in, using these connected IoT devices. Now, how does this entire IoT work? Now, as you can see, there are three parts, or 3 or 4 parts to this puzzle. On the left hand of your screen, you are seeing the controllers, right? So it could be a web application, it could be a mobile application, or it could be another IoT device that is trying to control the devices in the middle. In this case, we have taken a bulb and a refrigerator, which are our IoT devices. And basically, you can directly connect to them using HTTP. That was the old way of connecting these devices over internet and getting the things done. But more and more MQTT is used, which is short for message queuing telemetry transport, right? So basically, an MQTT broker has various topics. What you do is, when you have to do something or you want to get a status of a device, or you want to change the status of the device, you put messages onto a topic. So here you see a topic, and let's say the controller is going to send messages onto this topic to which these devices are subscribed, and then once the message reaches out to them, they are going to change their state or going to provide an information on another topic, from where these devices can or these controllers can take the information. So let's see this in action. So notice that a couple of messages are sent, right? So let's say this message is to turn on the bulb. So this message is consumed and the bulb is turned on, and then this message is consumed and the temperature of the fridge is reduced just by using a mobile app or a web app, right? Now, in addition to that, you may want that the information that is sent to the devices should also go into a database, or let's say an email should be sent, not only from this information, but let's say you realize that there is some problem with this particular device, or this fridge, for example, you don't have milk, right? And there's a way for this fridge to sense that, and it wants to send you a mail, or it wants to send you a message, right? So even those kind of things should be achieved. So here in this presentation, you see that there are three parties, the controllers, the devices themselves, and the backend. The backend can also be used to send messages for certain conditions that happen within the device, right? Or some status changes, or you may want this information to be captured somewhere from where you can draw your dashboards. Now, with AWS IoT Core, it takes care of two things, predominantly two things. It provides you an MQTT broker to which you can send and receive messages from, and put your controllers and your or put your command center, so to speak, and your devices together. And also you can use various rules and create actions so that any messages that are on this MQTT broker can then trigger, let's say, an email or writing to a database. And we're going to see a really good demo of this in this particular video. All right, so let's see what we are going to build through this two-part series, or simulate through this two-part series. So we're going to build a connected car, which we are going to exercise two functionalities. On the left hand of your screen, the car status is something that we are going to probe from the car. For example, what is the fuel level, what is the tire pressure that is reported by the car, and then using device shadows, which is a concept we are going to learn in the next part, we are going to command the car to be immobilized on the next startup if the car is stolen. But in this particular part, we are going to have the car send us car statistics, which are how many times the car has done hard braking, and or you have done hard braking while in a car, and how much peak speed did you attain during that interval. And based on that, your insurance provider can determine whether you are driving the car in the right way or in a risky way. So that's something we are going to do in this part 1, along with many other things. First, we are going to go into the AWS IoT console and try to understand some of the things there. Then we are going to install Node-RED. Then we are going to have some simple Node-RED flows that we are going to create. And after that, we are going to go ahead and do this car statistics demo, right? And we're going to build that Node-RED flow. All right, so off to the demo. All right, as always, I have logged into my AWS Management Console. I'm currently in the Singapore region, and I'm going to go ahead and click IoT Core. You can also search here. And now when I'm here, I'm gonna go ahead and create a thing. That is what we want to create right now, which is basically our connected car. So let's go ahead and do manage and things. And go ahead and create things. I'm going to create a single thing, and let me call it my connected car, the name of the thing. I'm going to leave everything as is, and I'm going to opt for no shadow as of now. We're going to learn about shadows a little bit later in the part 2. I'm going to go ahead and say next. And now we are going to talk about how we connect to the AWS IoT Core. But for now, I'm going to go ahead and say auto-generate a new certificate. When we use Node-RED to connect, we're going to talk more about the certificate and also our certificates. And we, if you go into the blog, part 1 of 2, here we have specifically talked about certificates, right? So I think it's here. Yeah, so anyways, so what we are trying to do here is we are trying to create a thing. So remember, we are in IoT, Internet of Things. So we are going to create a thing in AWS IoT Core. We came into here, we manage things, create a thing, and now we are going to go ahead and say next. So hold on, let me, yeah. So now what it is saying is attach policies to the certificate. So what all do we want to do with this particular thing, right? So I'm going to go ahead and create a very generic and expansive policy which is going to allow everything on IoT. So I'm going to say allow IoT, yeah, IoT, and I'm gonna say action as IoT star, which is here, and I'm gonna here delete this. I'm gonna say star and effect as allow, and I'm gonna say create. So this is allow IoT policy that is created, and notice that it shows up here, and I'm gonna click that. So basically to this particular certificate I'm giving this policy, right? So in a way I'm giving full permission to this thing. Now while on AWS you should only give permissions with least privilege, but for now, this is for the demo, we're going to give all permissions. I'm going to go ahead and create a thing. Now notice that at this point in time it's going to say download certificate and keys. These are what are required for us to connect to AWS IoT Core, and that we are going to do later when we install Node-RED. So for now, just go ahead and download everything. So I'm going to download the device certificate first, then public key file, private key file, and the root CA1 certificate. And again, I have talked in detail about what these certificates are. We're going to talk a little bit more about that when we actually connect using Node-RED. Now, I know for some of you, it might be a little bit difficult to actually follow everything. My suggestion would be to actually go ahead and do it along with the video, or go through the video once and do the hands-on, and you're going to really get a hang of this. Alright, so what we have done is we have created a thing called My Connected Car. We have given it a certificate so that we can connect, or set of certificates so that we can connect to our AWS IoT MQTT broker, and we have downloaded the required certificates. I'm going to go ahead and say done. So notice that this thing is now ready. Now before we do anything with this thing, what I also want to show you is the AWS MQTT broker endpoint. So we can go into setting, and we're going to use this setting a little bit later when we configure our Node-RED. And but for now, notice that this is our endpoint for MQTT. So almost think of it as our MQTT broker, which we talked about earlier in the presentation. Now, before we go ahead and install and talk about Node-RED, let's first go ahead and talk about, or let's first, try to just send some messages and receive those messages using this test option. So I'm going to go ahead and into the option test. So AWS IoT also provides a test client. It is good for some basic things, but for more important or more intricate prototyping, we should use Node-RED, which is what we are going to do a little bit later. So I'm going to go ahead and subscribe to a topic, and I'm going to call it topic 1, right? And go ahead and subscribe to that. So notice that there are no messages on this topic right now. And now what I'm going to do is I'm going to click here, publish to the topic, and I'm going to say IoT Core part 1, something like that, right? So now notice that once we publish here, the message should arrive here. So notice that we got the message here. We can also say to, and that message should also arrive here. So basically what we did was we subscribed to a topic, and we published to the topic, and we did get the message for that topic, right? So this is a very basic MQTT client. You can we are not going to use it anymore in this video, or at least not for the major chunk of it. We're going to use Node-RED because it is much more it has far too many options, right? Now how do we install Node-RED? So in this part of the video, we want to install Node-RED. So what we are going to do is we're going to go to Node-RED, just search Node-RED, go to node-red.org, and here go ahead and scroll down, run locally. I'm going to say getting started, run locally again, and here if you are using Windows, detailed instructions for installing Node-RED can be found here. So if you're using Mac or any other operating system, please use the instructions that are for that. But I'm running on Windows, so I'm going to go ahead and go to the instruction for Windows. Now for Windows, you need to have Node.js installed. How you can install it is so Node.js, just go ahead to Node.js, and you can go ahead and install the latest one, right, or the long-term support version. So I already have Node.js installed. Now what we can do is go ahead and install the Node-RED. Now just to make sure that you have Node installed, now what I'm going to do is I'm going to say cmd and right click and run it as administrator. Make sure you do that, and I'm going to say node ---- version and npm ---- version. So my node and npm versions are a little bit old, but they work. And the next instruction I'm going to use is this one, and I actually did install Node-RED earlier, but I'm gonna just run it anyways. So let's check that. Go ahead and run this command here. So now the installation is done. All we did was in node and npm for me was already installed, but if it is not installed for you, go ahead and install from here, and then just go ahead and run this command, which you can find out here, and that's that. So we already have Node-RED installed. Now once it is installed, it's fairly straightforward. Just go ahead and say Node-RED in your command prompt and enter. So notice that it says node server. So the prototyping server, basically the Node-RED server, is running at port 1880. So what I'm gonna do is copy that. Go ahead and copy that, new window or new tab, and that's it. Now we are greeted with a flow editor. So now what we have to do is what we did. So just want to see and check whether or not our IoT setup is working. I'm going to go ahead and get an inject node. Now this is again, there are a lot of documentations that are available for Node-RED, but if you actually just start working on it, it's much easier to actually learn as you do. And whatever we are going to do in this part 1 and 2, that's going to give you an enough understanding of how to use this. So I'm going to inject a timestamp, and I'm going to inject that into an MQTT outbound node, which is going to be on my and I'm just going to connect this together. Now notice that if I double click this, it says add a new MQTT broker. So that's what I'm going to do. So I'm going to edit that. I'm going to call it AWS IoT broker, and the server is going to be the one that we saw earlier here. So I'm going to go into settings within AWS IoT core, copy here, come here, paste that here. One thing to change is instead of 1883, make sure that it is 8883, and also make sure that the version is 3.1 legacy, and use TLS. And now this is where we are going to use all the certificates that we had earlier downloaded. So go ahead and enable this and select. Now for I already had some certificates that I had previously uploaded, right? But I can just remove those. Go ahead and remove that. Go ahead and remove that. So for you, this will be the prompt. Now we have to select the certificates that we had earlier downloaded. Alright, so let's go ahead and upload the device certificate first. I'm gonna click upload, and this is the one that I downloaded a little earlier at 10:21 today. So this is device certificate. This is a .crt file. That's, I think, the only .crt file that we have. So go ahead and copy that. Of course, you're gonna have a different file. So I'm gonna go ahead and open, upload private key. So this basically is a file which is named as private PEM key. So click that, and that's there. And CA certificate. So select this one, Amazon root CA. So the public key is not required. Again, we have mentioned that in our blog as to which is for what, and also provided a link. But anyways, coming back to what we're doing, I think we are good. So update. So we named our broker as AWS space IoT space broker. You can name it whatever you want. We pasted a server from here, right? From our settings, from here, settings here, and then we said connect automatically, change the port, and we said use TLS and added this configuration. We also changed the protocol to MQTT v 3.1. So that's really that. I'm gonna go ahead and say add. All right, so now we are back to editing the MQTT out node. I'm gonna go ahead and cancel here just to show you where we were. So we wanted to inject some information, so we bought an inject node. We connected that to an MQTT out node, and when we double click that, it said, look, you need to have a new MQTT broker, right? So obviously, since we didn't have any MQTT broker, we went ahead and added that. Now we want to send a message to a particular topic. So I'm going to say new underscore topic, something like that, and I'm going to say done. And also we want to check what message are we sending out to this new topic, right? So what I'm going to do is I'm going to go ahead and get a debug node and click it here. So this information is sent parallelly to the topic as well as to this payload. Again, once you start doing this, it's quite intuitive. Maybe just going through the video, you may not like it, or you may not feel like you know how to use it, but once you start using it, it's going to make a lot of sense. Now, anything that you do in Node-RED, make sure that you deploy it. So I'll go ahead and deploy that, and make sure you bring this debug window. So I'm here on the debug window. I'm going to click it here, and notice that it says, if I go here, this gets highlighted. So notice that it says message.payload, right? And it says this is the timestamp that was done, right? But when we click it, notice it also says that successfully injected timestamp. That means the timestamp has gone to the new topic as well. Now there is no way for us to actually find that out, whether that information has gone there or not. So for that, what we're going to do is we can subscribe to the new topic from here as well. But just for our initial test, we're going to go back to our AWS IoT. We know that we have a really good client here. So in the subscription, I'm going to go ahead and say new underscore topic. So we are sending from from Node-RED and trying to subscribe it from the AWS test client. Notice that even though we send two messages here, those messages haven't made it here. That's because if by default the behavior is if nobody is listening, the messages get lost. Now do learn or do understand this concept, because this is going to be extremely useful when we learn about shadows, which is one of the more confusing topics of AWS IoT Core. All right, so let's go ahead and now inject another message, and let's see if it comes here. And click. So notice that we have injected this new timestamp ending with 9041, and what do you know, we have it here. We can inject a few more, and they should all arrive here. So now notice that we have built a client here, right, which is injecting timestamp into this new topic, and also into a debug node, and we saw that the information is available on AWS IoT Core. So whatever setting that we did, they are all correct, right? Now we don't always have to go to this client. What we can do is we can also use an MQTT in node. So let's go ahead and do that. So I'm going to say MQTT in, and how we are sending this message. Now we are going to actually go ahead and subscribe to this MQTT topic, the same topic. So the name of the topic is new topic. Make sure that you change the QoS level to 0, and I'm going to go ahead and let me just name it also the same. Done. And now from here, once the message arrives here, what I want to do is I want to debug it, right? So just going to go ahead and get it here. And so now go ahead and deploy it. So notice also when you get connected, this thing should turn green and say connected. So now we are subscribing to the same topic to which we are sending message. So I'm going to go ahead and clean this up, and we're going to disable this node, because then when we send the message, it's going to show up here as well as here. So it's going to show it double here. So what we can do is we can just go ahead and disable this particular node so that you understand that functionality also is there. So I'm going to say done. So notice that this branch is now disabled. Deploy it before we do anything. And now when I inject, notice that the information arrived. And if I go here, so go ahead, now notice that this one gets highlighted. That means the message was sent from here to here and then it arrived. In fact, we can re-enable this and see this message appearing twice, one while sending, again deploy, clean the logs, receiving. So go ahead and do that, happens twice, and ending with 448 should also be seen here, right? So what we have built until now, or what we have done, is we have installed Node-RED. We have also configured AWS IoT Core, a broker in there, along with the certificates and private key and root CA certificate. And then what we have built now is a simple client where a timestamp is sent into the topic, and then we are receiving the same timestamp via subscription to that particular topic. And these topics actually, as we have seen in the presentation, they actually live on the AWS IoT broker, which is at this URL, right? So that's really that. All right, next up, what we want to do is we want to assume that instead of this injecting node to be an injecting node, this is actually our car. And what we want to do is for that car to send random information out for the number of heartbreaks that have been pressed, along with the timestamp and the number of times this particular what is the peak speed that was taken by that car. And that information should flow into a particular topic. Now we already know that we are able to do that, right? So this is not going to be there is nothing new in actually sending message to the topic. We have already done that, but here it's going to be a different sort of information. We are going to send a JSON information to a topic. So first, what I'm going to do is I'm going to go ahead and so we have to inject some information. I'm going to get the inject node, and we want to send it to an MQTT topic. So I'm going to say MQTT out. Let's call this topic slash car slash underscore stats, something like that. I think I'm okay with this. Go ahead and name it the same, right? And connect it here. Now notice that here it says timestamp, right? But it could be really anything. We can actually give it a JSON message as well. So let's go ahead and give it a JSON message, right? So I'm going to say that what I'm going to say is timestamp, right? And this is first time we are going to send a hard-coded message, and then I'm going to show you how we can send a different message every time. So let's go ahead and do that. And for the I'm just going to use go ahead and use this string as a timestamp, right? So this is a JSON message. Heartbreaks, let's say we did pushed heartbreaks so many times, and we are at 150 kilometers per hour, and put a comma here, so it's a valid JSON. I'm going to say done, and let me call this as data, something like that. Okay, so let's go ahead and say done. So notice that now once we deploy, that JSON should be sent to the car stats, and again we'll go to AWS IoT and see if that message has made it all the way there. So go ahead and deploy. So let's go ahead and go into test again, and again we can actually create a test like a subscription here as well, but let's do it here. So subscribe to a topic called car underscore stats. Let's go ahead and remove this subscription. Subscribe to car underscore stats. So no messages here. We deployed the changes. Let's go ahead and send the information. So now notice that we didn't debug it or anything. We could have actually. But notice that this information, whatever we put it there, it has arrived here. In fact, let me put a debug node in here. So again, you are going to, if you are new to Node-RED, you're going to find it a little bit difficult, but trust me, if you actually create these things along with me, again deploy, it's going to feel much more simpler. Okay, so go ahead and send. So notice that since we have a hard-coded JSON message, if we go here, notice this gets highlighted, means this is the message that we have sent, and we should have two messages now, the one that we had said earlier and now the one problem with this is that this message is static and we want this message to be a little bit dynamic, right? So let's go ahead and do that, right? So what we want to do before we send this message, right, we want to make it a little bit dynamic, right? So for that, what I'm going to do is I'm going to get a function, right, and put it right in the middle of this, and remove this one and this. So this function is supposed to change the information. Now again, for you, this code will be available, but for the sake of time, I'm going to go ahead and copy this. I'm going to explain what this code is actually doing. So what I'm saying is the timestamp has to be the current timestamp. The hard breaks has to be a random number between 1 and 20, and the peak speed has to be between 1 and 250, a random number. And then what I'm doing is I'm just assigning it to the message payload and returning that message. So this way, what is going to happen is when I send the data, this data will be sufficiently random, and we should see that here as well. So I'm going to go ahead again, deploy, and click here. So notice that now the timestamp is the current timestamp, the hard breaks are 13, peak speed is 43, click, click, click. So notice that every time we're getting different information, and similarly we should see all that information coming in here as well. The last one is 12, 2, 2, 3, and that's what that was, right? So now what we have done is we are able to inject some information and randomize it using a function and send it to the car statistics. Now the plan of this particular part 1 was to have this information captured into a DynamoDB table, right, or anywhere. So for that, in AWS IoT, we use something called as routes, right? So let's go ahead and try to set them up. Now, before we did that, because we want to send this to a DynamoDB table, let's go ahead and create a DynamoDB table. Now, I know some of you might not be aware of all these concepts or all the services of AWS, although we are not using many of those, but whatever we are using, they're not that complicated set of services, and we are barely scratching the surface of all of those as well. So anyways, the best advice I can give you at this point in time is just make sure that you run this along with me in the video, or what you could do is just go through the video once and run it yourself once more. Now let's go ahead and create a table. I'm going to call it car stats. Why not? And I'm going to say my partition key is basically this one, time_stamp. Let's go ahead and copy that, and it's going to be part of a string. Don't really care. Yeah, string should be okay. I think, yeah, string, and then go ahead and say create table. So in DynamoDB, it's a schema-less, no SQL data base, right? And the tables, you don't really have to specify schema. So notice that our table is ready. So now what we want to do is, without writing a single line of code, we want to take this information from this car, basically the car that is sending information to this topic, and take this information and put it into a table, from where then we can actually go ahead and use that information maybe to dashboard or analyze the habits of the driver, right? So let's go ahead and do that. I'm going to click again, I'm in IoT core. I'm going to go ahead and go into act. I'm going to say rules. I'm going to say create a rule and call it car stats rule, right? Car stats rule. And so basically what this does is it's gonna query our topic, so which is car_stats, and take everything and then take an action on it. So that's what we want it to do. So that's really, go ahead and say add action, insert a message into DynamoDB table, and go ahead and configure action, close this. So I'm going to choose a resource. We only have one table in this Singapore region, so car stats, and I'm going to say that the information that comes like this, right, timestamp, hard breaks, and peak speed, that should go into this table such a way that the timestamp partition key should be picked up from the time underscore stamp. So notice that I'm mentioning it into dollar and curly braces stamp. And then what I'm going to say is write the rest of the message information into stats column, right? Create a new column called stats, because currently all our table has is a timestamp partition key that we created. Now we're going to say write this message into this stats column, and I'm going to go ahead and create a role here and call it for stats dd for DynamoDB role, and create role. And so what we are saying is drop this information into car stats table. So add action, and we're saying that select everything from this car stats topic and put it into this DynamoDB table called car stats. So go ahead and create the rule. Now let's see this in action. So again, we change certain things here. So just I mean, even if you change this, the position, it's gonna ask you to deploy. So we didn't really change anything here between the previous demo and now, but yeah, so notice that I have to deploy every time this changes. So now again, we are going to inject some data. We should see that data here, and then we should see that data directly onto the DynamoDB table if this demo succeeds. So let's go ahead and do that. Click, 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 click. So I sent five data points, and if we go into the table now and view items, so 3 have made it here. So maybe yeah, so this is a little strange. This might be because before the rule came into force, we actually ended up sending a whole lot of data at it. Be the case. So I'm gonna go ahead and delete this once. Let's go ahead and delete everything and try this once more. Clear here. So 1, 2, 3, 4, 5, and come here again. I'm in this DynamoDB table, and let's see. I need to run this. So notice that now we got 6. I think this is some of the residual things that have just made it to it, although we did send only 5 things. And if I run it again, maybe is there an additional one? Yeah, so but most of the information, if you see from our second round, starting from 105 to 099, has directly made into the table. So 105, 104, so it has made it, yeah, it is actually 5, it's not 6. So yeah, so all the information that we pinged now, it has made it. So let's try a little bit more. So 1, 2, 3, 4, 5, right? And let's see if that has made into the table. Hit run. So yeah, now 1, 2, 3, 4, 5, 6, 7, 8, 9. Are we missing still another comment? But right, so now maybe let me run it again. 5, yeah. So anyways, so you get the point that when we send the data from here, from node red, that is going all the way from here to the car stats table, right, or car stats topic, and from there, using the rule that we had created, which is this car stats rule, which says pick up everything from this particular one and send it to the DynamoDB. That is basically happening, right? Just for the sake of completeness, we'll just run this again. All right, so 9 items made it here. We can debug and find out what is happening, why one of the items did not make it through. You do get logs for that, but for now, this was just to show you the concept that we can create a client here, send the data out into a topic, and from that topic, take that information and send it over into a table. And there are many more actions that can be done. So for example, let's go into rules, create a new rule, call it let's look at the actions. So notice that you can not only insert a message into DynamoDB, you can also send a message to Lambda function, and there are so many actions that can be done, right? So without writing a single line of code, you are able to send the message into the DynamoDB table. Now, in real world, basically, this function basically is what the device is going to be. So device is going to send a message to this topic, and then rest of the things will be taken care by AWS IoT rules and actions. However, this part, the device part, will be there coded on the device, either using AWS SDK or any proprietary mechanisms to interact with MQTT. But notice that without using any kind of device, we are just able to prototype our IoT solution, and these flows can get really complex as well. So yeah, I think that covers our part 1 of the demo. We are gonna go ahead and maybe rename this. Is there a way? I think there is a way to rename the flow. Yeah, so let's go ahead and rename that and make sure so let's go ahead and find that out. This is what we want to rename it as, so let's go ahead and paste it here and done. And why not, I'm gonna export this, and this should then be available. So I'm going to download this, and I'm going to rename it to the what we named it here, and make it available on the blog, so that you can go ahead and if you face some problems, instead of you doing this yourself, you can actually download this and import it using the Node-RED and get things going. So that concludes the part 1. Where let me summarize. We learned about what IoT is. We went through AWS IoT console. We talked a little bit about what MQTT is, what a broker, and the topics are. Then we installed Node-RED, and before that we actually used the simple client that is available on AWS IoT. Then we actually installed Node-RED, and we created a simple client to send to a fictitious, no, or not fictitious, the actual topic named new_topic. And we send the information from here. We received it in AWS IoT. Then we created a subscription for the same topic, and we received the same message back. Then we injected JSON information, which was fairly static JSON information, and we saw it arriving on the car_stats topic. But then we wanted to have a dynamic information, so we added a function in between, and that what all that function does is basically gives a current timestamp, random hard breaks, random peak speed, and sends it over to this topic. And then from that topic we created a rule so that the information actually goes into the DynamoDB table. And we did hit a snag where not all the information made it through, and I suspect the reason for that could be because if we send the information too quickly, the timestamp remains the same. So let's let me give you that example. So notice that this timestamp is 163.682.4154, 163.682.4154, and since that is our partition key into the DynamoDB table, this information only arrived once, right? So that is ending with 4154. This information only arrived once because it had the same key. So if we send the information really quickly, that's what happens. So let's go ahead and actually verify that. I'm going to go ahead and delete everything here, just so that we should have. Yeah, so let's go ahead, and so there is nothing in the table right now, and I'm gonna go ahead and send the information a little slowly so that it is sent on a new second every time. So refresh that, and let's wait for a second. So now we have sent 5 different messages, and let's go ahead and refresh that. So notice that we received 5 messages because all of them had the different timestamp. So 500, 504, 506, 508, and 511. So it's there's nothing to it's nothing about AWS not being able to send this information quickly. It's just that since our partition key has to be unique, and earlier it was not, the messages were not arriving, or messages were getting overwritten, I should say. So that's really that. That covers our part 1. Do make sure that you learn about some of the things that we have talked here within the blog, right? The blog has some more information. Let me go through the part 1 agenda. So we talked about IoT and MQTT, IoT walkthrough, creating a thing, what is Node-RED, we install Node-RED. So Node-RED is the prototyping tool, we just use that, using Node-RED to publish and subscribe messages, and AWS IoT rules demo. Now in the part 2, we're going to learn about device shadows and the AWS IoT core shadow service, and we're going to have a demo. This is one of the most or one of the more complicated parts of AWS IoT core. People find it a little bit difficult to comprehend, but we're going to try to take care or we're going to create a demo so that it makes it a little bit easier. All right, thank you very much, and happy cloud computing, everyone.